In section 10.4, we are going to be talking about biconditionals and definitions. Now, a biconditional statement, we're going to be looking in the gray box in the middle of page 614. Vocab word. A biconditional is a single true statement that combines a true conditional and a true converse. Remember, a conditional is an if-then statement, and the converse is when you reverse it. So both of them have to be true. You can write a biconditional by joining the two parts of each conditional with the phrase if and only if. So if and only if is a biconditional statement. Essential understanding. A definition is good if it can be written as a biconditional. So here is problem 1. What is the converse of the following true conditional? If the converse is also true, rewrite the statements as a biconditional. So in blue is our statement, is our original conditional. If the sum of two angles is 180 degrees, then the two angles are supplementary. That's true. If you have two angles that add up to 180, they are supplementary. So let's write the converse. So now the converse states, if two angles are supplementary, then the measures of those two angles is 180. Well, the converse is also true. So we can form a biconditional by joining the true conditional and the true converse with the phrase if and only if. So, we're going to take the converse, but we're not going to use if. So we're not going to use if anymore because that's a conditional. We're going to make a statement. This is a biconditional. The biconditional, which is your answer here, two angles are supplementary if and only if the sum of the measures of the two angles is 180 degrees. So right here, this is your biconditional statement. So let's look at our got it problem. Our got it problem at the bottom of page 614 says, what is the converse of the following true conditional? If the converse is also true, rewrite it as a biconditional. So, if two angles have equal measure, then the angles are congruent. So what would your converse be? Switch it around. What would it be? It would say, if two angles are congruent, then the angles have equal measure. So if two angles are congruent, then the angles have equal measure. Now, your biconditional could say, you could take your conditional here and says, if two angles have equal measure, then they are congruent. Your biconditional would say, two angles have equal measure, if and only if they are congruent. So two angles have equal measure, if and only if the angles are congruent. So it's taking the if and then out and putting in a statement using if and only if. Let's look at example 1 on the top of page 615. It says, if x is equal to 3, then the absolute value of x is equal to 3. If x is equal to 3, then the absolute value of x is equal to 3, which is true. So let's write the converse. If the absolute value of x equals 3, then x equals 3. That actually is false. The reason being is, what else can you take the absolute value of that gives you an answer of 3? Well, x could also be negative 3. So this is not necessarily true. You have a counterexample. X is also negative 3 here, so this statement would not work. We cannot write a biconditional, so the answer is false. You're done. On the key concept on page 615, it says, a biconditional combines P, if P then Q, and if Q then P, as P, and then you'll notice it's an arrow, it's like a line, and then Q. That symbol is called if and only if. So you would read that as P, if and only if Q. So an example of that would be, a point is a midpoint if and only if it divides a segment into two congruent segments. So let's look at the got it problem. Two numbers are reciprocals if and only if their product is product is 1. So if we look at the got it problem, we have to first, in the directions, this asks what are the two conditionals that form this biconditional. Remember, your conditional is your if-then statement. So we have if-then, which means your P and Q. So the first thing we do is just take it and put it into an if-then statement. From P to Q, if two numbers are reciprocals, then their product is 1. There's our first statement. The second statement is taking Q and reversing it to give you P. So if Q, then P. So now you just flip it around. So this statement would be reversing it. If the product of two numbers is 1, then the numbers are reciprocals. That's it. That's all you have to do. You have to write a conditional, and you have to write its converse, given a biconditional. So why don't you try practice 3 on your own? Write two statements from the statement, you live in Washington, D.C., if and only if you live in the capital of the United States. So write down your conditional and your converse. If you did, you would say the first conditional would be, if you live in Washington, D.C., then you live in the capital of the United States. Your converse would be, if you live in the capital of the United States, then you live in Washington, D.C. On the top of page 616 in the gray box, let's go over this together. Undefined terms, such as point, line, plane, are the building blocks of geometry. You understand the meanings of these terms intuitively. Then you use them to define other terms such as a segment. A good definition is a statement that can help you identify or classify an object. A good definition has several important components. Here they are. A good definition uses clearly understood terms. These terms should be commonly understood or already defined. A good definition is precise. Good definitions avoid words such as large, sort of, and almost. Those aren't precise. A good definition is reversible. That means you can write a good definition as a true biconditional. Here's problem 3. Is the definition of a quadrilateral reversible? If yes, write it as a true biconditional. Here's your definition. A quadrilateral is a polygon with 4 sides. So let's first write it as a conditional and then as a converse. So our conditional uses if-then. If a figure is a quadrilateral, then it is a polygon with 4 sides. That's our conditional. Can we reverse that into a converse? So our converse would say, if a figure is a polygon with 4 sides, then it is a quadrilateral. Is that true? Yes. The conditional and its converse are both true. So because it's both true, we're going to write a conditional and its converse as a true biconditional. Our biconditional would state, a figure is a quadrilateral if and only if it is a polygon with 4 sides. And that would be our true biconditional. So on page 616, we're going to look at the got it problem. In this definition of a straight angle, is it reversible? If yes, write it as a biconditional. So it says the definition of a straight angle is an angle that measures 180 degrees. So we have an angle, a straight angle, that is an angle that measures 180 degrees. So the first thing you have to do is write a conditional. So as we wrote our conditional states that if an angle is a straight angle, then it measures 180 degrees. So now we write the converse of that conditional, and that would say that if an angle measures 180 degrees, then it is a straight angle. So we have to look at that and ask ourselves, is that converse true? If an angle measures 180 degrees, is it a straight angle? The answer to that would be yes, it is true. So we can write a biconditional using if and only if. So let's write our biconditional. So our biconditional that we would write would be, an angle is a straight angle if and only if it measures 180 degrees. Notice that we did not use an if or a then. It's a statement that we use if the converse is true. So we can say an angle is a straight angle if and only if it measures 180 degrees. The last segment is problem 4. It says in problem 4 that we are going to be identifying good definitions. So we have to pick out whether a definition is good or not. One way to show that a statement is not a good definition is to find a counterexample. So let's look at problem number 4. Which of the following is a good definition? A fish is an animal that swims. B, rectangles have 4 corners. C, giraffes are animals with very long necks. Or D, a penny is a coin worth 1 cent. So we'll look at the fish first. Choice A, let's reverse it. A fish is an animal that swims. If we reverse that, we are saying that an animal that swims is a fish. The counterexample obviously is not good, so therefore A would not be the correct thing. A fish is an animal that swims would not be a good definition. Part B says rectangles have 4 corners. So then if we do a counterexample, something that has 4 corners is a rectangle, which we know is not true because, for example, a trapezoid has 4 corners, but it is not a rectangle. In C, it says giraffes are animals with very long necks. Very long is not a good, we can't use that because it's very generic. Other things have long necks, such as an ostrich, so that would not work. But lastly, D, a penny is a coin worth 1 cent. So if we switch that around, a coin worth 1 cent is a penny. That would be a correct statement. So D would be our correct answer. A penny is a coin worth 1 cent. That would be the best definition given to you in problem 4. So your vocabulary from section 10.4 is the word biconditional. So once again, tomorrow you have a vocab quiz. Please make sure you study sections 1 through 4.